Welcome to Lesson 5, Text to Image. In this video, we'll explore how diffusion models, the AI model behind image generators like the one ChatGPT uses, work. By the end, you will know how they take random noise and transform it into an image that perfectly matches your text description. What is text to image? While it may seem self-explanatory, text to image means you give the computer a sentence, like a castle floating in the clouds, and the AI generates a picture that matches that, as you can see in the example. The main technology behind this is called the diffusion model. But what is this model and how does it work? A diffusion model essentially learns how to make sense of randomness. Think about it like how smoke or gas diffuses randomly into surroundings. It's named after that type of randomness. A diffusion model learns to do two main things. First, how to take a clear picture, like the one of the dog on the left, and scramble it into complete noise, like the one on the right. Then, secondly, and more importantly, how to reverse that process, turning noise into the clear picture, like from right to left in the example. The end goal is to take this randomness and shape it into something meaningful based on the text input. You may wonder, why would image to noise, turning an image into a bunch of noise, ever be helpful? Well, you see that by teaching the diffusion model to do this, it learns the reverse as well, turning a bunch of random noise back into an image. When the model is generating an image, it starts with this pure random noise, as you see, like random dots of gray, kind of like how old TVs used to look when nothing was shown on. Then, little by little, it removes the noise in small steps, cleaning the picture up. But how does it know what to clean? Well, your text, like plane or truck in this example, guide the model towards patterns that match planes and trucks. The image gets sharper and clearer until the final picture emerges. But how does it know what planes and trucks look like in the first place? This is where image to noise comes in. Before the model can create images, it has to be trained. And training is done by giving the model a bunch of real images that we have added bits of noise to, then asking it to identify what part of the image is noise and what part is the real image. And we give the AI millions of these real pictures with their captions of what they represent in text, like cat for this example, and repeat this process of getting it to predict the noise we added, basically so it can separate out what is the real image and what is the noise. And by repeating this millions of times, it learns the exact steps of turning noise into meaningful images. But how exactly does the text come in? Well, it comes when we connect the text to the images. The model is trained on huge data sets where each image has a caption, right? This lets the AI connect the words with visual patterns. So when you type castle in the clouds, the model uses its training to guide the noise removal process into that kind of picture. In the example, you can see that the diffusion model was given an image of some clouds with the label clouds and an image of a castle with the label castle. And then when given the text prompt, castle in the clouds, it was able to create the correct picture, essentially by combining the two training images. This is just a small example, however. And in the real world, these models are trained on, up to billions of image caption pairs. Images and words do not relate on their own, however. To make this work, the system has two key parts, an encoder and a decoder, something you probably saw in lesson 4 about ChatGPT. The encoder takes your text and converts it into a numerical space that the AI can understand. Then the diffusion model works with and in this numerical space to shape the image until it's done removing the noise. And the diffusion model will output yet another, set of numbers in this space. That's where the decoder comes in. The decoder takes the image outputted from the diffusion model in numerical space and outputs the actual image that we can see. Think of it like the encoder translating English into the AI's language, then the decoder translating it back into pictures. So here's the whole process of text to image. It starts with your text prompt. An encoder translates your words into a set of numbers that capture their meaning. Then the diffusion model begins with pure noise in this number space and gradually sculpts that noise into a meaningful structure guided by your text. Finally, the image decoder takes this structured number representation and expands it into the full resolution picture you can actually see. And this is how AI transforms words into images. Thanks for watching.